A quick video on how to use particles for water simulation in Maya. I have a very simple scene with a chute, a bucket, and a particle emitter. And that particle emitter just shoots out particles and they flow down the chute into the bowl, but they do not fill up the bowl. And you all know why that is if you're in my class. That is because there is no self-collision at this point. If I turn on self-collision, they will actually no longer fall on the slide. They just go haywire. That is because they are so close together that they push each other apart. You can, if you in collisions scroll down a little, you can set the self-collide width scale. So how much they can intersect, basically. If you put it on 0.5, they can half intersect. So if I play it again, they are staying together a bit more. And they do fill up the bucket. If I do it on 0.25, it's even nicer. And the fact that we're seeing overlapping spheres here is not going to matter by the time we render, because we would render this as a blobby surface. So they fill up the bucket nicely, and then if the ball falls into the bucket, they just explode. That's not very much splash-like. You want them actually to give a nice splash and stick together. The regular particle simulation does not allow for like surface tension or particles to stick together, so they just go everywhere. So instead of using self-collide, and I say instead of because you don't want to have both of them active, you can go and turn on liquid simulation. That's found a little bit lower in the properties. Here's liquid simulation. If I enable liquid simulation, they behave differently. They again go completely haywire. That is because the particle liquid radius size is also 1, which is the same as the actual particle size. We need to put that into a similar range, like 0.25 for instance, to get these big particles to nicely flow down the chute. And they do fill up the bucket, but you see they stick close together. And if the ball hits the bucket, you get more of a splash than a explosion of particles. So what are the important parameters in your liquid simulation? You've got incompressibility, how hard it is to compress it. So if you put that on 2, it will be harder they also explode more. It will be harder for the ball to compress the particles. And the ball is coming right now, and off. The rest density determines how many particles will be how close the particles will be packed when they're in rest. And the viscosity determines how sticky they are, how much they want to stick together. So if we put the viscosity all the way up to 1, it should be a very slow flowing liquid, very high internal friction. So you see they takes very long to fill up the bucket, and then when the ball hits it, hardly anything happens. So those are important parameters if you're playing with particles as for liquids. The finishing touch to get this to work nice is to, in the particle size, to at the beginning make them a little bit smaller so they don't explode as they get birthed, as they start, and set that base just on H, so they start off small, slow, and then start growing. So let's see what that looks like. That's a bit better in the beginning, and then they nicely fill up the bucket, and as the ball hits it, it should get some kind of splashy effect more than a big explosion of particles. So that's a really quick and dirty video on how to use liquid simulation on particles to simulate water.